Good evening, dear viewers, and thank you to join me. Sorry, this is the small update for all of you. We have to change, we have to make small change in our session. Due to summer, we are going to change the time. The upcoming sessions will start according to Indian Standard Time, 8:30 p.m. So now the sessions will be start later 1.5 hour from the previous scheduled time. So please keep note this timing. We have to make this a small change. So first I would like to see how many viewers join us, and then we will start. Okay, so please let me know. I think everything is fine. If you have any question, you can put your questions in the chat box. Okay. So first of all, I would like to share my screen with all of you. So today in the session, we are going to discuss three methods. Sorry, there will be two methods, and one is Adam Bashforth Moulton method, and the second one will be Hamming method with the modification formulas. So along with we will discuss here Rangata fourth order method. Okay. The most important thing is that this method already has been discussed in the last session, but still this will help us in many ways to understand the other two methods, which are Predictor and Corrector. Two methods will be used here, and the most important thing is when we are using Predictor and Corrector method, by choosing one of these, like Hamming method or Adam Bashforth Moulton method. In these two methods, we need some initial values, and these values can be computed or calculated with the help of Rangata fourth order method. We can use Euler method as well as Taylor series. So one of these method we can use to calculate four values which are required for Adams Bashforth Moulton method and Hamming method. So Predictor and Corrector both are very simple method and highly used for the different type of calculations for the approximations and provide us more accurate solutions. So first we need to check about this method, which is Rangata fourth order. So when for this method we have, this is the main equation, and this equation involve fk1, fk2, fk3, fk4, and these values can be easily calculated by these four equations. Okay. So here along with the we have to discuss here with the particular example how we can write MATLAB code to compute this when we are given a differential equation. See, along with we have, this is the MATLAB code is also there, and for this one we are choosing this example. You can see dy upon dt is equal to, we have t exponential 3t minus 2y, and this is the initial condition. For the interval we have 0 to 2. So at this place we are going to discuss a very simple way, and we will cover, or we will discuss, three methods at this place. So here we are choosing h. H is the increment or the distance between two consecutive points when we have the partition of given interval. So this is the value of h, or the size of step. So this is the size of step. Size of step. Okay. And comment this one. Yes. And this is the initial value. This value is minimum and this value is maximum. So we are denoting by T minimum and T maximum. Alpha. Alpha is the initial given condition. And you can see here, initial value we have is when T is equal to 0, Y is 0. So we are denoting this initial condition with the, and N is number of maximum iterations which are required. Okay, so this will give us the number of iterations, T max minus T minimum upon H, and this is the H value. So from this place we can easily get the value of number of maximum iterations which are required for our simplification. Okay, T1, what is T1? T1 is when we apply the loop, or you can say the first value. Okay, T1 is the first value from the interval from 0 to 2, and we have partition of this interval and having the several points, and step of each size we have is 0.1. Okay, so these are only parameters which are used for the initialization of our problem. After that, we want to calculate the initial value for Rankata method, for Hamming method, for Adam-Bashforth method. Okay, see here we have AB. AB is Adam-Bashforth, and the second one is Moulton. Okay, so these are the values for the initialization of these three methods, and y1 is the particular value for the analytic solution. Okay, now see here, for beginning of loop 1, which is the initialization which are required for 4 points when we are using Rankata method, or we are using Adam-Bashforth Moulton method, etc. Okay, so here you can see this is I is equal to 2 to 4, and for I equal to 1 we have this is the initial value for each which are above we have taken already. So one value for each we have at this place. In these three equations we have when t equal to 0. T equal to 0 means T1 is equal to T minimum and minimum value of T is 0. Okay. So including this condition and for this point, we have 4 points. Okay. See here this is T is equal to 1, And when we have these two, when we will expand, this will be 2, 3, and 4. Okay. So corresponding to this point, we have when we extend this iteration. Okay. This is not the time. This is the index of the time. Okay. Our interval is divided like 0, 0 0.1, 0 0.2, 0 0.3, and so on up to 1. Sorry, 2. So here this is T1, this is T2, this is T3, this is T4, and so on. So this is the just indexing over the interval after partition of the interval. Okay. So when we will extend, when we apply this loop, we have the point with the interval. This will give us the value of T2, T3, T4, okay, by using the initial loop. So corresponding to these, we have the value of K1, the value of K2, the value of K3, value of K4. How we can get these values and from where these values we have, you can see this is K1, this is K2, this is K3, this is K4. At this place we have FK1. We can denote it by this is K1, this is K2, this is K3, this is K4. So from these three equations, we can have this one. This is K1, K2, K3, K4, and the final formula. Okay. Also, you need to note at this place we have FD. Okay, what is FD? FD we have, you can see this is derivative. And the value of FD means FTY, we have this one. This is the given differential equation. TEXP 3.0 product T minus 2y. This is the same as we have. I explained that we are taking this differential equation. And these are the conditions, initial conditions, and we want to find out the solution for this interval. Okay. Now you can scroll down and note these equations. This is the K1, K2, K3, K4. Okay. So our main formula is at this place, this one, yk is equal to by 6 fk1, 2 fk2, 2 fk3, fk4, and we have at this place this one. So this is just the notation for Rankita fourth order. Okay. So here this is the latest final value which will be given by the equation which I have shown here, the equation number 6.3.1. Note this equation very carefully, and along with you need to understand the syntax in the MATLAB. Okay, so this is the corresponding syntax. This is the left hand side of the same equation. Okay, and this is the previous value, and this is the final value. So here you can see the recurrence difference, which is 1. Okay, and these are the value of K1 to K2 to K3, K4, and divide by 6. So this equation, this will give us the numerical value by using Rankita fourth order method for the given differential equation. Now we want to discuss here Adam Bashforth Moulton. So the first four values we can get by using this Rankata method, and after that we can easily use Adam Bashforth Moulton. So here you can see W underscore AB Adam Bashforth is we have Rankata fourth order. Similarly, this equation gives the four values for Adam Moulton. That is also equal to the same. Okay, so we are preparing to use or to use the equations which will give us the solution, numerical solution, by using Adam Bashforth Moulton. And the equations for the same we are given here. Yes. So here you need to note carefully for the predictor we have pk plus 1 is equal to yk plus h upon 94 minus 9 fk minus 3 plus 37 fk minus 2 minus 59 k minus 1 plus 55 fk. So here is k plus 1 and here is k minus 1, k minus 2, k minus 3. So these are four unknowns. The values of these four unknowns can be easily computed or calculated with the help of any other method like Rankata fourth order. We can use Euler method as well as we can use Taylor series. Okay, so in this method, at this place we are using Rankata fourth order method. So first four values will be calculated by Rankata fourth order. Then after we will be able to find out the solution of the given differential equation by using Adam Bashforth Moulton method. Then this is the modifier. This will modify the value which is mk plus 1 is equal to pk plus 1 plus 251 upon 270 ck minus pk. And then we have corrector which is ck plus 1 is equal to yk plus h by 24 fk minus 2 minus 5 fk minus 1 plus 19 fk plus 9f tk plus 1 mk plus 1. So this value will be used at this place and this value is used at this place. Okay, and ck plus 1, the corrector value will be equal to this formula which is given in equation number 6.4.8c. And also you will see that this value is used at this place. Okay, to update the value, to correct the value. Okay, so while writing the MATLAB code, first you need to understand about the method, then this will help you to write the MATLAB code. Okay, so here I am not expanding about more the establishment of the formula, derivation, etc. Just the main purpose here is how we can write the MATLAB code for these numerical calculations. Okay. Otherwise, the lecture will be too long and I will not be able to complete in one session. So here, this is the predictor, this is the modifier, and then we have the corrector, and the final value will be given by this equation. So now come here. Along with the exact solution we have is this is the exact solution is given by here yi is equal to fti and the FTI. We are calling the function at its place T. Yes, this is the exact solution. I write here the function, the exact solution in the form of a function, and then I call this function this place. Note this point very carefully. Sometimes when we have the computing part is long, then we can divide in several parts, and sometimes we need to create a different function, a user-friendly function, so that the program becomes friendly. Okay, so here is called the exact solution, which is created in the user friendly function. Okay, so this is the solution. This is the solution, and this is the given differential equation. Okay, so these two both are we create two functions in a several script file, and then we are calling at its place. Okay, so here this is the exact solution. Now this is the difference between the solutions, exact solution, and the solution by using rank of fourth order. This is the absolute value of yi and rk. Okay, and we are denoting it by difference of rk 4, and here is absolute error between yi and the solution given by Adam Bashforth Moulton, and these differences are stored at this place and here. Now we are beginning the main loop. Main loop will start from 5 because I is equal to 1, 2, 3, 4 already has been taken. Now I equal to 5 and beyond all the values. So this is the total number of the sub interval, and the number of points will be number n max plus 1. Okay, so we will apply the loop here. Now corresponding to this, we need to find out all the points, and this advanced time will be given by this equation. Ti is equal to ti minus 1 plus h. So when we have I is equal to 5, this will be t5, and t5 will be equal to t4 plus h, where h is the step size. Okay, so in this way, for all the points which we have for the interval, t is equal to interval we have is 0 to 2. Okay, so all the points which we have for the same interval, uh, after dividing into the sub intervals. Okay, so we will apply for loop for all the points to get the value. This will give us the vector for time. Now see carefully these two equations. These two equations are predictor equation. Okay, and this is quite simple. See this part yk, then we have h by 24. See here, this is the h by 24. Then we have 55 up to this one. 55 fd ti minus 1 WAM I minus 1. Okay, see these 2 points. First is 55 FD. Okay, here is 55 FK. F is the function whose we are going to find out the approximate solution. So this is dy upon dx, dy upon dt, f by fty. Okay, so when we have tk and yk, this will be equal to fk. Okay, so we want to find out the value for this one, for this one. Okay, so now see here, yeah, and then we have 59, and this value, the equation is divided into 2 parts, and for these 2 points, these two, fk minus 3 and fk minus 2, see, these are at its place. 37 FD, then Ti minus 3, comma, WAM I minus 3, minus 9 FD, Ti minus 4, and WAM I minus 4. See, this value and this value, minus 9 and 37. This is minus 9, this is 37. So this part and this part are same. You can write these 2 equations in the single part, but to make easy, we can write in this way also. And after that, in the same way, we have Adam-Moulton step corrector. We are directly using here, okay, for this part, this whole part, okay. So you can easily convert into in this form. You can see WAM, this is the Adam-Moulton step corrector, and the previous is the predictor, this is the corrector. Okay. So you can compare this equation with here, and easily you can convert in this form. Okay. So this is also the same as we discussed for the previous equation, and you can easily convert for the Adam-Moulton for the corrector. Okay. Now this is the Rankata method. You can see here for I equal to 5 to the maximum value. And here also we are getting the difference for these values. Okay, so these are the same equations as we discussed above. The exact solution is given by this equation, and these 2 equations are representing for absolute error. Okay, and then we have end. So when we apply for loop, we need to close by using end function. So this is the for loop starting from this place to this place to get all the values for both the functions, both type of solutions. One is Adam Bashforth, second is Rankata fourth order. Now exact solution. Okay, see the exact solution, we have the fine grid, this is the t last and is equal to t minimum, y fine is equal to alpha, this is the initial value, and h is equal to h by 10, and beginning the loop for this one, we can have for I is equal to 2 to 10, and maximum plus 1. This will create the loop for all the point, and this is the t fine and this is the y fine. These are the final values of ti, yi. Okay, y fine will be equal to f t fine. Okay, and t last is equal to t fine. So after that, we want to plot. So here is plot the result for w and y. This is the plot for w, t, w, r, k, vector fourth order, and this is the plot for w underscore Adam Bashforth. Okay. So then after, this is the plot for exact solution. So we have here three graphs. One is using by Rankata fourth order, one is analytic solution, and one is Adam Moulton method. Now at the end we have, these are the labels. These are the labels. One is a title. You can insert a solution to dy upon dt is equal to t exponential 3t minus 2y. And x label we have time, y label we have y. Legend one is Rankita. Second we have Adam Bashforth Moulton. And third we have the exact solution. Okay. So here is A must be capital, B is also must be capital, and M must be capital. So dear participant, if you have any question, you can put your questions in the chat box. Okay. So after that, you need to get the numerical solutions also, and you can do here file 1. This is the one which is t dash. File 2 we have y dash. Then we have file 3 which will be the Rankata fourth order. Then we have file 4th we have the difference of Rankata. Okay. Then we have Adam Moulton method. This will be the difference, absolute error, exact and Adam Moulton. Okay. And all these numerical solutions will be saved in this file. Save the output underscore pc file hyphen ASCII. So the numerical solutions of these equations will be saved in this file. So this is the overall about the programming for these two methods. And now we are able to execute this script file. When you will execute this script file from this place, and you can find we have the solution. Okay, so by using the exact solution, Adam Bashforth Moulton and Rankta fourth order, all the graphs are coincide, and you can find the graph of by using these three methods. Along with in the output, this is the output file. When you will double click on it, these are the numerical solutions. Okay, so the first interval is P, then we have Y, this is the exact solution, this is the solution given by Rankta fourth order, then this is the absolute error, this is the solution given by Adam Moulton, and the last column is absolute error. Okay, so this is the way to find out the solution. Also, when you will close this file, yes. So all the columns which you have seen in the output file will be in this order. So first we have time, then we have y, then we have rank of fourth order, then we have the absolute error between the exact solution and the rank of fourth order. Then we have fifth column, we have the solution given by Adam Moulton, and the last column we have the absolute error between the analytic solution and Adam Moulton solution. Okay, so in this way we can easily find out the solution of these questions. Now the another way to find out the solution of the same, we have one another way, but the method will remain same. Okay, so if you can have some questions, you can put in the chat box so that I can check all these queries. Good evening, all of you. Vani and okay, Anthony, Aya, okay. Uh, sorry, today we make a change in the our schedule. If you have question, you can put in the chat box. Okay. So I hope you are understanding all these questions. The content which we discuss here is helpful for all of you. If you have a question, good evening, Vani Madhavi, Antonia, Ania, okay, and okay. What happens if the function called is not opened or not on the system? Yeah, when you don't have the function, then the program which we write here will not execute. Okay, because the solution will return only if when we have all the supporting file. If you are creating the user friendly function, then that must be in the same folder. Okay, only then we are able to find out the solution. See here, see in this file, here is FD and this file. This file is in the same folder. You can see here. This file is opened at its place. If you close this file, doesn't matter. But the script file which you create the functions, okay, these must be there. Or if you don't want to create, you can write these functions in the same program. But this will create some difficulty for you. If we create the function in the script file separately, user-friendly function, then this will make you easy to use anywhere. Okay. So now I want to close this one. Now we discussing here. Okay. So here you can see this is the Arankita fourth order method which we discussed in the last session. Okay. And here is also we want to use, but this is the different way to use Arankita fourth order method for ordinary differential equations. Okay. So for this at its place, we want to find out the solution of the equation. The solution of the equation which is the the differential equation is dy upon dt is equal to minus y plus 1. Okay, and the initial condition is y 0 is equal to 0, is equal to 0. Okay, so we want to write a program in such a way that can be easily used for all type of differential equations, which are ordinary differential equations. Okay, with the initial condition C, and the interval is yes, the interval is say 0 to, okay, so this interval is time span. Now come to its place. First, you need to understand the Rankta method and how many parameters are involved there. So the most important thing is we want to apply Rankta fourth order method for this differential equation, and ft y is equal to this one. Okay, this is the differential equation. So this is the f function. One is f function. Then we have t span. T span means the given interval. This one. Then we have the initial condition, which is this one. Then we have n. How many number of iterations we want to apply? This is n. Then we have Varargen. Okay, what do you mean by Varargen? I explained in the last session. See, yeah. So one is Nargen. Nargen means number of input arguments, and Varargen means variable input arguments. How many variables are input argument list? Okay, so this is the only the use, and by using these make errorless function the code. Okay, so here we have this equation, and t span will be equal to in this form. Y naught is the initial value and n is the number of time steps. Okay, how many steps are there? Okay, so this is the way to use. If Nargen is less than 4, use here this one. Yeah, or n is less than or equal to 0, n equal to 100. And for the Nargen, for the initial condition also, which Nargen is less than 3, y naught is equal to 0. We end at its place. Now, what do you mean by this one? This will create row vector for y. So this will start from the initial value, and then when we have the first solution, second solution from this place, so all the values will be updated at its place. Okay, and this is the h. H is equal to t span 2 minus t span 1 upon n. Okay. If you want to check in the command window, we can do here. See, if we have t-span is equal to we have this interval 0 to 10. So press it. Then we have h is equal to n equal to 100. N is equal to 100. Then copy this part and paste here. So this is the h value. H is 0.1. Okay. T-span 2 means 10. T-span 2 means this value. And T-span 1 means this value. And n is the number of steps which are required. This will give the value of h. So in this way you can verify these values, and when you will have this one, this will generate time vector. See, and t is equal to you will have these values. This is the time vector. Okay. So now all these points by using the for loop will pass through to get all the values till the final value. We are using here for loop. You need to understand this method very carefully for the other two methods which we are going to cover here. This will help you in many ways to understand the other methods. Okay. So here is, this is the F1. F1 is nothing but the first equation. Nothing but the first equation. Yes, this one. This is F1, FK1, FK2, FK3 and FK4. Okay. So here is F1, H, F1. This will compute the value, function evaluation. This will calculate all the values for F. F is the function. Note the syntax very carefully. This is very important. Just 1 minute if possible for me to make the full size for this one. Okay. Then come here, scroll down. Yes. Now see. This is the function evaluate. So this is the dy upon dt. Okay. Is equal to f t y. Okay. So here is tk. This is tk. This is yk. Because the values will vary from the t vector 1, 1.1, 1.2, 1.3 and so on for up to 2, and corresponding to these value will be calculated for f function by using f evaluate function, and then we will convert this value in the column vector. Okay. Similarly, we have F2. We are calculating here. The same equation is there, which we can see. These equations, all these equations are used at this place. Okay. So just note the MATLAB code and don't make any error. when you will write for the when you will write the program for ranked fourth order. Okay. So now come here. This is the complete MATLAB code. Then we have this method is complete. There is no error in this code. Okay, your code must match with this code. Otherwise, if there is very small error, your program will not work properly. Then we have T here. This is the Adam Bashforth Moulton method, and the yes, yeah. So this part, predictor, modifier, and corrector. You just need to convert these equations. So the part, this part is same, no change here. Only Kc is new, and Kc will be equal to 1. You can see. And Tf, T-span, Y naught, N, all these are same. Only one new parameter is there. Okay, and the most important thing is all these three methods are used for the same differential equation. Okay, so F1 again less than 5, Kc is equal to 1 with the modifier by default. Okay, and these are the same condition as we discussed for the ranked fourth order, maximum number of iterations which we need to require, and these equations are also same. Okay, as we do in the very first method directly, the same steps are here. To for the Bashforth Moulton method, to initialize, we need 4 initial values. Okay, and this will be calculated by data method for initialize. So the same method we are using here, which we write the code at its place. This code is we are using here to find out the solutions for the initialization. Okay, so here is T-span 1, 0 to 3. So this will give us 4 points. These are the 4 values. 0 to 3 means 0, 1, 2 and 3. These are 4 points. So 4 point will be generated from this equation, and 4 values will be calculated by using ODE ranked fourth order. Okay, and we will convert all these values in the T vector form. Now, by using these values, we want to calculate for the k, for k is equal to 1 to 4, fk, f1 for the function f, tk, yk and vark. Also along with you can see here p values are required, c values are required. C in the method, p values and c values. These are the c values and these are the p values. Okay, here also p values are used. So for the same, these values are the particular values which are based on first 4 values for the initialization. Okay, also here you will see KC22, okay, and KC22 is equal to KC251 by 270. Note this point very carefully. This symbol is used for this one, and this is Kc. Similarly, we have KC12 is equal to KC into 19 by 270. 19 by 270. This part. Here is 19 by 270. And this is KC. Also, here is H24 is equal to H by 24. This one. H by 24. Then we have H241 is equal to this value. H241. 1 minus 5, 19, 9. Yes. This is 9, 19, minus 5, and this is H by 24. So only the coefficient are chosen here. 1, minus 5, 19, and 9. Similarly, H249 is equal to H24 minus 9, 37, minus 59 and 55. These values are the coefficient of this equation. Okay, so in the case of polynomial, only we are choose coefficient. Okay, so only the coefficients of fk minus 3, fk minus 2, fk minus 1, fk are taken, and similarly at this place these coefficients are chosen. Okay, so now there are P1 is equal to, P1 means this equation. Okay, P1 means this equation. So this equation now in a very simple manner can be written as yk comma colon, the values of t will automatically pass at its place, H249 into f. Similarly, we have M1 modifier. This will be P1 plus KC22 product C minus P, and this is the corrector. Okay, so corrector will be C1 is equal to YK plus H24 product F24, and this value will pass. Okay, note this. This is the corrector equation. This whole equation. Okay, and then after we have the final solution. Yk plus 1 is equal to C1 minus KC1 to C1 minus P1. Now we need to update the values. Okay, so P is equal to P1, C is equal to C1, and update the predicted corrector values, and at the end we have F is equal to this statement F24 F1 T Ftk plus 1 Yk plus 1. All the values will be stored in F for our use. And in the same manner, we have the Hamming method. There is very small difference between the Hamming method and the Adam-Bashforth method. Okay, so all the things will go parallel. You should note all these statement. I will not take much time. You must compare all these statement. So when you will write the code, you must take the screenshot of this file. Okay, and this is the complete code. Once again, above line, first line, and then the up to end. So this is the complete code of the same, and this is the method, Hamming method. Yes. So all the things will go parallel. This is the predictor, then we have modifier, then we have the corrector. And these steps are also involved in the Adam Bashforth Moulton method. Okay. So here is also k minus 1, k minus 2 for k plus 1. Okay. And k minus 3 is also there. So corresponding to this, you have to write the procedure will be same. First, you need to find out first 4 values by using Rankata fourth order. So up to this place, the same process. Then this is the P1, this is the M1, this is the C1, and this is the final value, and then you need to update. Okay, predicted corrector. So the code is very quite simple, and I make a full once again note carefully all the statement so that this will make you very helpful. Yes. Now I hope you can take the screenshot of this file for your use. So we have now 3 programs. One is for ODE Rankata fourth order, and second is for Adam Bashforth method, and third one is Hamming method. Okay, and all these methods are stored in the user-friendly function. We can use these functions for any kind of given ordinary differential equation, and we can compare all these also. Now come here. So at this place we have the differential equation which must be evaluated with the initial condition and the interval. So here T naught is equal to 0, Tf is equal to 10, Y naught is equal to 0. These are the starting, final time, the initial value. N is equal to, we are choosing here 50 number of segments. DF643, this is the just assignment, nothing more. This is the inline function which the differential equation to be solved, okay, which is minus y plus 1. See, this is minus y plus 1. Here is minus y plus 1. We are using here inline function. This is inline function, okay. This is the t and y. T is independent variable, y is dependent variable. And the analytical solution of the given differential equation we have is 1 minus exponential t, okay, and this is the function of t only. After that, for kc is equal to 0 to 1, okay, for kc is equal to 0 to 1. So here we have TIC is used to calculate the time for the Rankata method. So here is, this is the differential equation. This is the differential equation. See here. Here is F and here is DF643. So this is the differential equation which will be called at this place automatically. Then this is the time span, this is the initial condition, this is the number of iterations, and TR is equal to TOC. So this will calculate the time for this method. Similarly, we are going to find out the solution for ABM method, and rest all the things are same. You can note here. Okay, and same we have the ODE for Hamming method. Okay, so this is the analytical solution. Now we are plotting these 4 methods, and this is very quite simple. You can see here is subplot 2 to 1 KC2. Okay, so this is the plot T1 YT1K. This is the analytic expression. This is the analytic expression. This is the solution given by Rankata. This is the one is YR, one is YA Adam, and this is given by Hamming. So we have 4 solutions, 4 graphs will be there. So these are the only absolute errors. Okay, and see here the subplot for the same. This one and this one are same. Okay. Now run this file. So these are the 4 graphs you can see here. These are the corresponding graphs. And if you want to check the time, remove the semicolon from this place. The time for each method has been calculated here. Okay, for Hamming we have 0.0143, for the Rankata we have 0.0211, and for the Adam Barsh we have 0.0121, and for the Hamming we have 0.0161. So the least time is taken by this method. So this is the all about this method, and I hope the content which I present here really very helpful for all of you. If you have question, please feel free to ask from me, or you can put in the chat box. There are some questions in the I can see in the chat box. Good evening, Oluvasai. Can you share the script file? How can I share this file? How I can share the file? Yes, I want to share, but how you can get the file? So thank you very much to see this lecture till the end.